Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique hexagonal pyramid having edge of the base 30 mm, axis height 65 mm, and it has got one of its slant edges resting onto the ground or onto the horizontal plane. So let us first of all evaluate the orientation of this hexagonal pyramid onto the horizontal plane. If we locate hexagonal pyramid onto the horizontal plane in this orientation and then we tilt the hexagonal pyramid either this way or this way, so it will be resting on one of its edges onto the ground, and if we tilt it completely onto the horizontal plane, it will be resting on one of its triangular faces onto the horizontal plane. So this does not satisfy the requirement of this problem that the hexagonal pyramid has got one of its slant edges resting onto the ground. So here you are going to get one triangular face which will be resting onto the ground rather than one of the slant edges resting onto the ground. So if we locate the hexagonal pyramid in this orientation, now whenever we are going to tilt this hexagonal pyramid through this apex either this way or this way, so when we tilt it completely over here such that this apex point, it is going to lie onto the horizontal plane. So we are going to rotate it up to the point when this slant edge OD, so it will be completely contained by the horizontal plane. So now we will see that this slant edge, it is going to be contained by the horizontal plane. So this way, the first condition which has been laid out into this problem, so this will be fully satisfied. So this way, this is the correct orientation of the hexagonal pyramid onto the horizontal plane. So now in the second iteration, we have been provided with a situation that this slant edge which is contained by the horizontal plane or resting onto the horizontal plane and the plan of the axis. So the plane containing these two edges over here, that is the edge OD and the plan of the axis OO1. So the plane which is containing these two edges, this will be perpendicular to the horizontal plane, and this plane is further inclined at an angle of 45 degrees with respect to the vertical plane. Here we have got an oblique hexagonal pyramid which happens to be inclined with respect to the horizontal plane as well as inclined with respect to the vertical plane. So we are required to obtain the orthographic projections of this hexagonal pyramid when the apex of the pyramid, it happens to be nearer to the vertical plane than the base over here, right? So let us first of all proceed with the construction of the orthographic projections of the hexagonal pyramid when this pyramid is resting on its base onto the horizontal plane to begin with. So whenever the observer is going to look at this hexagonal pyramid from the top, so the observer will be viewing the hexagonal projection onto the horizontal plane below the XY reference line into the top view projections over here. So we know that the edge of the pyramid, it happens to be 30 mm. So using the edge length 30 mm, we have drawn the hexagonal projection onto the horizontal plane over here. So let us now label these points A, B, C, D, E, F. Now let us evaluate the axis point corresponding to this hexagonal pyramid. So for that we need to join the diagonals AD, BE and CF over there. So wherever these three diagonals they are going to join, the intersection point will provide us with the location of the axis points O and O1. So here O is the apex point, whereas O1 it is the axis point which is lying at the base of the hexagonal pyramid. Now when the observer is going to look at this hexagonal pyramid from the top, so all the 6 slant edges, they will be visible to the observer. So we will be getting OA, OB, OC, OD, OE and OF slant edges drawn with the help of object lines over here. So this way we have completed the construction of top view projections of the hexagonal pyramid resting on its base onto the ground. Now let us proceed with the construction of front view elevation projection of this particular hexagonal pyramid. Now we will see that point A of the base, it will be projected as A dash onto the XY reference line. Points B and F, they will be projected as B dash and F dash onto the XY reference line. Similarly, points C and D of the base of the hexagonal pyramid, they are projected as C dash and E dash onto the XY reference line. And finally, the point D of the base will be projected as point D dash onto the XY reference line. Now here we have axis point O and O1. Now from this particular axis point, we have drawn the axis projecting this axis into the elevation view over here. Now we know that the length of the axis happens to be 65 millimeter. So now we have marked this axis length is equal to 65 millimeter. The moment we mark the height of the hexagonal pyramid, the apex point we have been able to locate. So this apex point happens to be O dash. So from O dash, which is located at a height of 65 millimeter from the base of this hexagonal pyramid, now we need to join the slant edges O dash A dash, O dash B dash, O dash C dash, O dash D dash, O dash E dash and O dash F dash over here. Now one thing we need to clearly understand that the slant edge OF, it is lying on the rear side of the pentagonal pyramid. So this will not be visible to the observer. So the front view projections of the corresponding slant edge in the front view O dash F dash should have been drawn using hidden line or the dotted line projections over here, but they are not visible to us as a dotted line projections. Why? Because the slant edge OB, which is appearing in the front face of this particular hexagonal pyramid, so this is overlapping with the rear slant edge OF over here. That is why the front view projections corresponding to the slant edge OB, that is O dash B dash, they will be superseding or they will be superimposing upon the dotted line or the hidden line projections corresponding to the edge O dash F dash over here. Similarly, the projections corresponding to the edge OE, so because it is lying on the rear side of the hexagonal pyramid as it is viewed by the observer from this direction, so the front view projections corresponding to the slant edge OE, that is O dash E dash, similarly should have been drawn with the help of dotted line or the hidden line projections over here. But since the projections of the slant edge, which is OC, which is appearing to the observer in the front side of this hexagonal pyramid, they are overlapping with the rear slant edge OE over here. So that is why in the front view, the hidden line projections which are represented by O dash E dash, so they will be superimposed by the object line projections corresponding to the slant edge OC over here. That is why O dash C dash projections, they are drawn with the help of an object line, while O dash E dash projections, they have been drawn with the help of hidden line projections or the dotted line projections over here. So since O dash C dash object line projections, they have superseded or superimposed upon the hidden line projections corresponding to the slant edge O dash E dash. So we are not able to see the hidden line projection over here. So this way we have got all the projections corresponding to the slant edges appearing in the elevation projection view as object line projections over here. Now we are provided with the information that this hexagonal pyramid is inclined with respect to the horizontal plane in such a way that one of its slant edges, that is O dash D dash, it happens to lie onto the horizontal plane or it happens to lie onto the ground. So one of the slant edges which we have chosen as OD over here. So here O dash D dash we have to rotate in such a way. So this hexagonal pyramid we have to rotate in such a way that this slant edge O dash D dash, it should be lying onto the horizontal plane. So now we are not given that the axis of the hexagonal pyramid is inclined at a certain angle or the base of the hexagonal pyramid, it is inclined at a certain angle. So now the slant edge has to be rotated in such a way that it should be contained by the horizontal plane. So now you can see we can mark this distance corresponding to the slant edge length over here, which is equal to O dash D dash. So this point we have marked as O1 dash. This point we have marked as D1 dash. So this distance between O1 dash and D1 dash, this happens to be equal to the length of the slant edge O dash D dash over here. Now, having marked this edge length, now we are required to transfer or rotate the front view projections of this right pentagonal pyramid into this new rotated or the transformed view when one of the slant edges will be contained by the horizontal plane. So how this can be done? So using rectilinear distances, we will be able to obtain all the other points of the front view elevation projection which we had obtained earlier. Now please check. Now we know the distance between D dash and A dash over here. So once we know this distance D dash A dash, so with D dash as center, now we will open an arc and draw an arc having radius equal to the distance D dash A dash over here. So one arc we are going to draw over here. Similarly, now we know the point D dash. Similarly, from the point O dash, we know the distance of this slant edge O dash A dash over here. So this length of the slant edge we also know. Once we measure this slant edge length O dash A dash, now with O dash as center, we will mark another arc having radius equal to O dash A dash such that this arc should be intersecting the earlier arc which we had drawn, which was having the radius is equal to D dash A dash over here. So this way point A1 dash can be located into the elevation projection view over here. Now once we have located the orientation of D1 dash, A1 dash, now we know the distances of these 3 points over here. That is the distance between D dash and C dash E dash. So this distance we are going to mark it over here. So points C1 dash and E1 dash, they will be located here. Similarly, we also know the distance between C dash, E dash and O1 dash. So this distance we are going to mark appropriately over here. So point O11 dash can be evaluated alongside D1 dash and A1 dash length of the base over here. Thereafter, we are going to measure the distance between O1 dash and B dash F dash over here. So this distance once we measure and we mark this distance over here, so points B1 dash and F1 dash will also be located. So once we mark all these points of the elevation projection view into the transformed or the rotated view over here, so using rectilinear distances, we have been able to obtain the rotated or the transformed projection of this hexagonal pyramid when it has been rotated in such a way that it is going to rest on one of its slant edges onto the horizontal plane. Now, having obtained the front view elevation projections of this hexagonal pyramid, now we are required to obtain the top view projections of this hexagonal pyramid over here. Now, how that can be done? Now, we can see as the observer is going to look at this hexagonal pyramid from the top. So, how many points do we have in the front view elevation projection view? 6 points corresponding to the base they are available, 2 points corresponding to the axis. So in all we have got 8 points available with us in the elevation projection view. Now corresponding to this inclined hexagonal pyramid, 8 points they are available in the elevation projection view. Now from each one of these 8 points, we are going to draw the vertical projector lines and we are going to extend these vertical projector lines into the plan projection view over here. Now we are going to draw the horizontal projector lines from the corresponding points of the plan projection view which we had obtained earlier. So these are the 8 points which are available with us. Now through these 8 points, we will be drawing the horizontal projector lines, and then the intersection of these horizontal projector lines with the corresponding point vertical projector lines we are going to obtain, and we will be able to obtain 8 points in the plan projection view which will be the corresponding point. So let us start with evaluation of these plan projection corresponding point. So first of all, we have got these 2 points F and E over here. So through points F and E, let us draw a horizontal projector line over here. So wherever this horizontal projector line emerging from the points E and F, this will be intersected by vertical projector lines emerging from E1 dash and F1 dash. So these points of intersection will provide us with the location of the points E1 and F1. So please check. This is point E1 dash in the elevation. So we draw a vertical projector line through E1 dash. We have drawn horizontal projector line through point E. So this intersection point will provide us the location of the point E1 in the plan projection view. Similarly, this is the elevation projection point F1 dash. From F1 dash, we have drawn a vertical projector line from point F. In the plan projection view, we have drawn the horizontal projector line. Wherever these 2 projector lines they have intersected, we have been able to obtain the point F1 in the plan projection view. Then over here we have got 4 points which are falling into the same horizontal line, A, D, O and O1. So through these 4 points, again we have drawn a horizontal projector line. So wherever this horizontal projector line emerging from these 4 points A, D, O and O1, it is going to intersect with the vertical projector lines drawn through D1 dash, A1 dash, O11 dash and O1 dash. So these 4 points we will be able to obtain. So please check, this is point D1 dash. The vertical projector through D1 dash, it will be intersecting with this horizontal line emerging from the point D over here. This point of intersection provides us with the location of the point D1 in the plan projection view. Similarly, this is point A1 dash. So from A1 dash, again we have drawn a vertical projector line. Now, whenever this vertical projector line intersects with this horizontal projector line drawn through the point A, so this point of intersection will provide us with the location of the point A1. Similarly, here we have got point O1 dash. From O1 dash, we have drawn a vertical projector line. From point O, we have drawn a horizontal projector line. The intersection of these 2 projector lines has provided us with the location of the point O1 over here. And finally over here, this is point O11 dash corresponding to the axis point of the base. Now from O11 dash, we have drawn a vertical projector line. wherever this vertical projector line intersects with the horizontal projector line drawn through the point O1. So this intersection point provides us with the location of O11 over here. And finally, we have got these 2 points over here, B and C. So through B and C, again we have drawn horizontal projector line. So wherever this horizontal projector line will be intersecting with vertical projectors drawn through points B1 dash and C1 dash. So this is B1 dash. If we draw a vertical projector line through B1 dash, wherever it will be intersecting with this horizontal line, emerging from point B, we are able to obtain point B1. This is point C1 dash. So from C1 dash, again we have drawn a vertical projector line. So wherever this vertical projector line, it has intersected with horizontal projector line drawn through point C. So we have obtained the point C1 over here. Now, having obtained all the 8 points in the plan projection view, now we need to join different edges over here. What are the edges which we have to join? A1, B1, C1, D1, E1, F1, A1, and all the slant edges O1, A1, O1, B1, O1, C1, O1, D1, O1, E1, and O1, F1. Now, which one of these edges they will be drawn using object line? Which one of these edges we have to draw using the hidden line or the dotted line? Let us evaluate. Now you can see over here, as the observer is going to look at this inclined solid from the top. Now the farthest edge or the farthest points which are there away from the observer, they happen to be D1 dash and O1 dash. It means that all the edges joining O1 in the top view and D1 in the top view, they should be drawn dotted unless those edges they are going to fall in the boundary of the solid. So let us start joining these edges over here. Now we have just discussed that all the edges joining D1 should be drawn as dotted, but we have joined D1 E1 dark, we have joined C1 D1 dark. Why we have joined these two edges dark? Because these two edges, they are constituting the boundary of the solid. And moreover, as the observer is going to look at the solid from this side, so this outline of the hexagonal base, this entire base will be visible to the observer. So this is falling in the boundary, so that is why it will be visible to the observer as well. Now let us start joining the slant edges over there. This slant edge O1 F1 and O1 B1. So these two slant edges, they are falling into the boundary. They are forming the boundary of the solid. So they have been drawn dark. So again, we have violated this thing that all the edges joining O1 should be drawn dotted. So since these two slant edges O1 F1 and O1 B1, they are forming the boundary of the solid, so they have to be drawn dark. Similarly, O1 E1, O1 D1, O1 C1 over here. So these three slant edges, they have to be drawn dotted. Why? Because they are not constituting the boundary of the solid. O1 dash, D1 dash lies onto the horizontal plane. So this edge will not be visible to the observer, as the observer is going to look at the solid from this side. And finally, one slant edge is left yet, that is O1 A1. So please check, these two edges we had drawn using object line because they were constituting the boundary of the solid. But there is another slant edge O1 A1. So if we look at the solid, you can check O1 dash A1 dash lies on the top surface of this hexagonal inclined pyramid. So since O1 dash A1 dash, it is lying on the top surface of this inclined hexagonal pyramid, so the top view of this slant edge, that is O1 A1, so this should be drawn dark over there. This should be joined using an object line, but we have already got a hidden line starting from O1 to D1. So O1 D1, it is the hidden slant edge over here, whereas O1 A1, it is the object line that is, it is going to be joined by a dark line which is going to indicate that this slant edge OA, this will be visible to the observer as the observer is going to look at this object from the top side. So this way we have been able to obtain the front view projections as well as the top view projections of the inclined hexagonal pyramid when the pyramid is resting on one of its slant edges onto the ground. Now we have been provided with the situation that the plane containing the edge, that is O dash D dash, which is resting onto the ground and plan of the axis. So you can check, this is my plane. This is the plane I am talking about now. O, O1 and D. So this is the plane and it is represented as an edge view over here. You can check, this is O, this is O11 and this is D. So if we are going to look at this particular inclined pyramid from the top, so O, O1 and D. So this plane, it happens to be perpendicular to the horizontal plane, because if it happens to be perpendicular to the horizontal plane, so its projection on horizontal plane will appear to be an edge view. This is a plane O1, O11 and D1 over here. So this is the triangular plane now you see we are talking about. So we have to visualize this thing that this is a plane O, O1 and D over here. So over here it is represented as O1, O11 and D1. And this is perpendicular to the horizontal plane. That is why its projection on the horizontal plane, it is appearing as a edge view over here. Now this plane which is containing the edge OD and the plan of the axis, you can see this is the plan of the axis. Since this axis O1 dash, O11 dash, which was the true length of the axis, which happens to be 65 millimeter. So this length of the axis was 65, but since it was inclined with respect to the horizontal plane, so in the top view projection we have obtained the plan of the axis being projected over here as O1 and O11. Now this plane, which is this triangular plane over here, O, O1 and D. So this is perpendicular to the horizontal plane, and in the second iteration we have been provided with the information that this plane, which is represented as an edge view onto the horizontal plane, this is further inclined at an angle of 45 degree with respect to the vertical plane. So please check, we have marked this orientation line at an angle of 45 degree, and now we have to transfer these plan projections which we have obtained corresponding to the inclined hexagonal pyramid over here in such a way that apex should be near to the vertical plane. So apex point will be located here, and rest of the hexagonal construction which we have obtained over here, it has to be transferred over here at an angle of 45 degree with respect to the vertical plane, such that points O1, O11 and D1 should be lying alongside this orientation line at an angle of 45 degree. So using the principle of transfer of the rectilinear distances, we are going to rotate this particular plan projection view from front orientation to another orientation where apex point will lie here, axis point will lie here, and point D will lie over here. Now we observe over here that this hexagonal construction, it has been inscribed into this rectangle over here. Now this rectangle we are going to draw at this particular position. The hexagonal construction will be made over here while the apex has to be located over here. Now we can check, this is the rectangular construction which we have made corresponding to this hexagonal projections which we have obtained in the top view projection over here. So this is the longer edge. We have drawn the longer edge over here. This is the shorter edge of this rectangular construction. Again, the shorter edge has been constructed over here using rectilinear projection transfer over here. Now we can see between these two edges we have got point 1, point 2 and point 3. So we can measure the distances of point 1, point 2 and point 3 from the extreme ends over here. So these three intermediate projection lines we have drawn over here. Now we know that these are 2 points, these are another 2 points, here we have another 2 points, and this will be our center point, and here the apex will be located. So you can check all the 8 points which were available with us in the previous plan projection view. So they have been transferred using the rectilinear distance transfer method over here. So once we locate all of these 8 points, now we can transfer this plan projection view from this orientation to this orientation over here. So apex, we have been provided that apex should be located nearer to the vertical plane than the base. So base is facing the observer, apex is away from the observer and closer to the vertical plane. So this way we have been able to obtain the top view projections of an oblique hexagonal pyramid in which the pyramid was rotated with respect to the horizontal plane in such a way that one of the slant edges was contained by the horizontal plane, and then the plane containing that edge which is resting onto the ground and the plane of the axis, it is further inclined at an angle of 45 degree with respect to the vertical plane. So now corresponding to the oblique solid, the top view projections have been obtained. Now let us obtain the front view elevation projections for this oblique hexagonal pyramid. Now how this will be possible? When the observer is going to look at this hexagonal pyramid from this orientation, then how many points do we have in the front view projection? Total of 8 points they are available in the plan projection view. So from each one of these 8 points, we need to draw the vertical projector lines and extend them into the elevation projection view. We have already got the elevation projection view for the inclined hexagonal pyramid which we had obtained earlier. Now from each one of these 8 points, we are going to draw the horizontal projector lines into the elevation projection view and find out the points of intersection of the corresponding points in the elevation projection view. So wherever the points of intersections of the vertical projector lines drawn through the plan projection view points and the horizontal projector lines drawn through the elevation projection point views, they will be obtained. So the elevation projection view points, they will be located corresponding to this oblique solid over here. So let us proceed. First of all, we have the point A1 dash available with us. So from A1 dash, we have drawn a horizontal projector line. So wherever this horizontal projector line emerging from the point A1 dash, it will be intersecting with vertical projector drawn through the point A2. So this point of intersection will provide us with the location of the point A2 dash in the front view projections over here. Similarly, next points which are available with us, they are B1 dash and F1 dash. So from B1 dash, F1 dash, again we have drawn a horizontal projector line. So wherever this horizontal projector line will be intersected by vertical projectors drawn through B2 and F2 over here. Please check, this is point B2, this is point F2. So the vertical projector drawn through B2 intersecting with this horizontal line will provide us with the point B2 dash in the elevation projection view. Similarly, the vertical projector drawn through point F2 intersecting with this horizontal projector line emerging from F1 dash will provide us with the location of the point F2 dash over here. Next, we have got the point O11 dash. So once we draw horizontal projector line through O11 dash, right? So wherever this horizontal projector line will be intersecting with the vertical projector line emerging from axis point of the base O21. So we are going to obtain this intersection point as O21 dash over here. Next we have got these 2 points C1 dash and E1 dash. So from C1 dash and E1 dash, again we have constructed a horizontal projector line. Now wherever this horizontal projector line will be intersected by the vertical projectors drawn through the points E2 and C2. This is C2, this is E2. So wherever it will be intersected by vertical projectors drawn through C2 and E2, so we will be obtaining the points C2 dash and E2 dash over here. So here we can check vertical projector through C2 intersects with this horizontal line emerging from C1 dash over here. So we obtain C2 dash. Similarly, vertical projector through E2, it intersects with horizontal projector line emerging from E1 dash over here. So this intersection point provides us with the location of E2 dash. And finally, we have got these 2 points D1 dash and O1 dash. So again, we draw a horizontal projector line through O1 dash and D1 dash. So this is going to coincide with the XY reference line. Now wherever this horizontal projector line is intersected by the vertical projectors drawn through the points D2 and O2 over here. This is point D2. So let us draw vertical projector through D2. It intersects with this XY reference line over here. We obtain the point D2 dash. Here we have the point O2. So once we extend this upwards, so it intersects with the XY reference line at this point, obtaining the point O2 dash over here. Now all the 8 points of the elevation projection view, they have been appropriately located over here. Now which edges we need to join? A2 dash, B2 dash, C2 dash, D2 dash, E2 dash, F2 dash and A2 dash, and then with the apex O2 dash, A2 dash, O2 dash, B2 dash, O2 dash, C2 dash, O2 dash, D2 dash, O2 dash, E2 dash and O2 dash, F2 dash needs to be joined. Which one of these edges should be drawn dark or with the object line, and which one of these edges need to be joined with hidden lines or the dotted lines? Let us evaluate that. As the observer is going to look at this solid from this direction, so the farthest point away from the observer happens to be O2. So anything joining O2 dash in the front view projection should be drawn as a dotted line unless that particular edge constitutes the boundary of the solid. And the hexagonal base, because it is facing the observer, so total hexagonal face, this should be joined as a dark line. So please check the hexagonal base we have joined as dark edge. Now we discussed that anything joining O2 dash should be joined dotted unless it is constituting the boundary. So please check O2 dash, D2 dash is constituting the boundary. Similarly, O2 dash, B2 dash is also constituting the boundary. So these two boundary slant edges, they are there. O2 dash, D2 dash, O2 dash, B2 dash. And then we can see O2 dash, A2 dash should be joined dotted. O2 dash, F2 dash should be joined dotted. And O2 dash, E2 dash should be joined dotted over here. Similarly, O2 dash, C2 dash should also be joined with the help of the hidden line over here. Why? Because O2 dash, C2 dash does not constitute the boundary over here. So we are going to get 4 slant edges over here joined with the help of dotted lines, whereas the slant edges falling into the boundary, they have been joined with the help of object lines or the dark lines. Now we can join the axis also. So this is the axis point or the apex point O2 dash. This is the base axis point O21 dash. So now we have marked the axis over here. So this way we have been able to obtain the orthographic front view projections, orthographic top view projections of an oblique solid which happens to be inclined with respect to the horizontal plane in the way that one of the slant edges is rotated such that it lies onto the ground or it lies onto the horizontal plane, and thereafter the plane containing the edge which is contained by the horizontal plane and the plan of the axis, so this is further inclined with respect to the vertical plane at an angle of 45 degree. So with this we complete the discussion of the oblique hexagonal pyramid, which is inclined with respect to horizontal plane and with respect to vertical plane as well. So we are going to continue with further discussion regarding few more illustrative cases of projections of the oblique solids in the coming lecture discussions over here. So thank you very much. Thanks a lot.